Bit more history, the structure of the atom. The fact that the atom is made up of smaller particles was first identified by J.J. Thomson when he used a cathode ray to identify the presence of electrons. We know a cathode ray is an X-ray, and essentially what Thomson did is he fired an X-ray at a metal target inside of a glass container and knocked electrons off, creating a stream of electrons that a magnet would bend. And so that was the way he identified negative particles inside of a neutral atom. Robert Millikan is known for his oil DOP experiment, and he was able to uniquely separate the charge of an electron from its mass. Thomson was only able to figure out the charge-mass ratio of electrons. Our final atomic structure researcher was Ernest Rutherford, and he was able to identify the structure of the atom itself, where and how the nucleus was put together, and what exactly was inside these atoms that people had been able to identify. And he did this using gold foil and shooting alpha particles at it. What we're going to spend a lot of time looking at is the structure of the atoms and how they're held together, bonding between them. The strength of the bonds and the type of the bonds that are formed between these atoms depend on what atoms are combined, first of all. They also depend on whether the electrons are shared in the bond or transferred from one atom to another. If they are shared in the bond, we have a covalent bond, and we have two kinds of those. If the electrons are transferred from one atom to another, then we create ions, and that forms an ionic bond. Our two kinds of covalent bonds are polar, where electrons are shared between two atoms but shared unequally. The other kind is a nonpolar bond, where the electrons are shared essentially equally between the two atoms. Ions. You should know the symbols and the charges for essentially all the ions on the ion sheet. In Moodle, up at the top under references or resources, I can't remember the name, is an ion sheet. All the monatomic ions and the polyatomic ions that are in bold, you should know those names, you should know those symbols, and you should know the charges. And so flashcards or whatever it takes for you to memorize those, the expectation is, like you know the alphabet, you know those ion symbols, names, and charges. When I'm writing compound formulas, when I'm naming them, a couple of different compound combinations I can have. First one, the easiest, is if I take a metal plus an anion or a negative ion and form a compound. And this can be, so the anion is the negative ion, and it can either be an elemental ion. If that's the case, the ending is IDE for the ion name. If it's a polyatomic, there are a variety of endings. They can be ATE, as in sulfate, they can be ITE, or they can be IDE. And here's where the memorization comes in. You'll need to know their names. So if I'm naming a compound, for example, if I wanted to name this compound, I'm going to name the metal first, that's sodium, and I always write the positive ion first, with one exception. Then I'm going to name the negative ion, and the ending is going to be the ion ending. It's not going to be the element. So the element is chlorine, but I'm going to change the ending of the element name and make it chloride. If I wanted to do another compound, let's say potassium sulfate, again, I name the metal first. K is potassium. This time I have a polyatomic ion. It's the sulfate ion, and so I just name that. If I have two nonmetals, then I'm going to have a covalent bond. With covalent compounds, I may need to use a prefix, and that identifies how many of each element I have. So I'm going to name them in the order that they're shown. So if I have something like SO3, S is sulfur, the first element is just named as the element. The second element has the IDE ending, so it's going to be oxide. But I don't have one, I have three of them. So I have to use the prefix for three, which is tri. My first element, if it has only one, then I don't have to worry about a prefix. If I have a compound where both elements have more than one, something like this, again, I'm going to name the first element as its element name, so that's nitrogen. The second ion is the IDE ending, so that's going to be oxide. But now I have to put prefixes on both element names because I have more than one of each. So my prefix for 2 is di. My prefix for 5 is penta. Or I just leave off the A and it's pentoxide. So if you're not sure of your prefixes from 1 through 10, that would be another thing to memorize. 1 is mono, 2 is di, 3 is tri, 4 is tetra, we're doing Greek here, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. We can keep going, but we're going to work with compounds that don't have more than 10 atoms in the compound. If I'm naming an acid, there are two different ways that I can do this. If I'm dealing with a binary acid, I have two elements, hydrogen plus some nonmetal. When I name a binary, the hydrogen becomes hydro, the nonmetal becomes whatever the element stem is, ended in IC, and then the second word is acid. So if I have HCl, I have hydro. My element nonmetal is chlorine, so it's chloric. If I have H2Se, again hydrogen, and the nonmetal selenium, it's going to be hydroselenium, so that's selenic. If I'm naming oxyacids, which are acids that have a polyatomic as their negative ion, the naming procedure is a little bit different. So we'll start out with this acid. So I always start with hydrogen, and now I have a polyatomic ion. My polyatomic ion is nitrate, and here my polyatomic ion name ending dictates the acid name. So when I have an ATE ending, it becomes an IC in the acid, so this becomes nitric acid. So you're going to have to learn the names of the ions and then how the name changes. So if I have an acid like this, I don't say anything about the hydrogen in either of these cases, so I'm focused on my negative ion. It's a sulfate, so it's going to be sulfuric acid from the ATE ending. I can also have H2SO3. This is a different polyatomic ion. This is a sulfite ion, so it has an ITE ending. So the acid name is going to be different. It's going to be sulfur, and the ITE ending goes to OUS, so sulfurous acid. So the homework should give you some practice in naming some of these. You'll also be able to write the name from the formula. When you're dealing with transition metal compounds, the unique thing about transition metal compounds is those metals can have multiple ionization charges or multiple oxidation numbers. When you write the name, you need to identify which ion charge you're working with. For example, I can have these two compounds, both contain copper and iodine. Iodine is nonmetal, generally has a negative charge of -1. So in my first example, I have to use that knowledge to allow me to figure out the charge of the copper ion. So when I name it, similar to naming other compounds, metal compounds, I'm going to name the metal first, so it's copper, and it's iodide. Now to identify the charge of the copper ion in this case, I'm going to use a Roman numeral. And this charge on copper in this particular compound is copper 1, so I'm going to call it copper 1 iodide. The other copper compound, again, contains copper, contains iodine, so it's going to be a copper iodide as well. But here I have two iodide ions to one copper, so that means that copper must be a +2 in this particular compound to show that I'm going to have the Roman numeral 2. So this is copper 2 iodide, different from copper 1 iodide in the above problem. So that takes care of naming, that takes care of ions, and that's primarily what Chapter 2 is all about.